Christina, can you read us the essential question, please? Perfect. Amy, can you read us the I can statement? Perfect. All right. This is really the last. There's a lot more to trig that we have not gotten to, unfortunately, and we're probably not going to get to just because of time. Okay. Those of you that move on to calculus, we will probably try to pick some of that up toward after we take the AP test next year. Okay. So I will make sure that you've at least seen it. All right. So that way, if you go on to college and it comes up again, you've at least learned it in high school somewhere. Okay. So we are going to learn how to solve an equation that has trigonometry in it. Okay. We've taken a lot of baby steps already to doing this, so we're close. We just have to have that last little bit. Okay. In these first few, we just have to verify that these numbers or these radian measures are solutions to that equation. Okay. So that's all that they're asking us to do in those first couple. So what I'm going to do is I'm going to plug in the 7 pi over 6 for x. So let's try that. So I'm going to go 2 sine of 7 pi over 6 plus 1. I am checking, does that equal 0? Because I don't know. Okay. All right. So we're going to go to our unit circle. And I'm going to find sine of 7 pi over 6. Is sine the x coordinate or the y coordinate? Y coordinate. Okay, so I'm going to go to the y coordinate and I'm at 7 pi over 6. I'm at 7 pi over 6. I'm looking at y. So I am going to put in the negative 1/2. And I'm still testing. Is it equal to 0? I don't know that it's equal to 0 or not yet. Okay, what happens with these 2's? Cancel. So I've got negative 1 plus 1. Is that equal to 0? Yep. So that one is a solution. Yes, it worked. Or true. You go yes or the word true, something like that. Okay. I'm going to do the same thing. I'm going to plug in 5 pi over 3. So we've got 2 times sine of 5 pi over 3 plus 1. We're checking, does that equal 0? All right. You guys already told me that sine is the y coordinate. I'm going to go to 5 pi over 3. So it looks like I am putting in negative square root of 3 over 2. I'm checking, does that equal 0? All right, what happens with the 2's? They cancel. So negative square root of 3 plus 1, does it equal 0? No. So this one would be false or no. All right, I'm going to start the next one with you, and then I'll have you probably finish it on your own. Don't write super big because it takes up more steps than the last one. I'm looking at my work from last year. Okay, so try to write smaller. All right, what's wrong? Yeah. Got it? Okay. All right, so on example 2, I have to determine pi over 8 and 3 pi over 8. And this, I've got this little square down here to deal with. So I'm going to move that to the outside. Okay. So what I'm really doing is 4 parentheses sine of 2 times pi over 8. And then the squared goes on the outside minus 2. I'm checking to see, does that in fact equal 0? And the I can statement said multiple angle. Okay. When I have that 2 next to the x, that's what they're talking about for a multiple angle. Okay. Because we have a number in there because the angle measure is what always goes in by the sign. All right. What happens with the 2 and the 8? Cancel. How many times does 2 go into 8? 4. Good. So I have 4 times the sine of pi over 4 squared minus 2. We're checking to see, does that equal 0? All right, I want you guys on your unit circles, go find the sine of pi over 4 and write it in there. Everybody's going to find that on their own this time. All right, what do we get? Good. Square root of 2 over 2. Perfect. I'm now going to square both of those things. So when I square the square root of 2, remember I just get 2. What happens when I square 2? 4. Good. Minus 2 equals 0. All right, what happens with these 4s? Cancel. So we've got 2 minus 2. Does 2 minus 2 equal 0? Yep. So that first one is, in fact, a true value. Okay. All right. I did a much better job of squishing it in this year. I want you guys to try the 3 pi over 8 on your own. Okay, so put in 3 pi over 8. It eventually will end up as something on your unit circle, but follow the same steps we just did and determine, is that a value or is that a true value for that equation? Okay, I want you to check it with somebody at your table. So talk about it with somebody at your table, double check your work. Okay, let's take a look at it together, make sure we've all got it. How many times does 2 go into 8? 4 times. So we've got 4 out here, sine of 3 pi over 8, whatever we get for, sorry, I'm doing it wrong. 3 pi over 4 squared minus 2. We're still checking, does that equal 0? What's the sine of 3 pi over 4? What do we get? Square root of 2 over 2. What's wrong? We okay? Do we understand the 3 pi over 4? I took 2 into 8 4 times. We okay, Levi? Were you the one saying not? Levi, were you the one saying that you didn't get it? Huh? You good? Okay, I'm sorry. I just wanted to make sure we're good. Okay. All right. What is the square root of 2 squared? 2. 2 squared. 4. All right, so these 4's cancel. 2 minus 2, does it equal 0? Yep, so this time they were both true. Okay, so they could both be true. They could one be true, one be false, and both be false. Okay, or maybe there's only one of them that they execute to verify and plug in. Okay. All right, we're going to change the instructions a little bit. We're not going to do degrees. We're going to go ahead and do radians on all of them. It's basically going to be the same instructions as the last one. So 0 to 2 pi. And notice for our answers, technically the way that this is reading is that 0 is included and that 2 pi is not included. Okay. I want you to double check your unit circles before we do this problem. Okay. On your unit circles, make sure it not only says 2 pi, but 0 for the radians. Okay. Because it's both right there. Okay. So what we are supposed to do is we're supposed to find all the solutions to the equation on the interval from 0 to 2 pi. So we're not talking inverse trig where there's only two places, two answers. Okay, we're talking, we have to look at the entire circle and see if we'll find all the places where this is true. Okay. All right, thanks. So I'm looking for I've got to figure out what the angle measure is for when the cosine is equal to negative square root of 3 over 2. Okay. So I start by asking myself, is cosine the x value or the y value? X. And we've done something similar to this before. Okay. So we're kind of baby stepping it back up here. So I'm going to go find all the places where the x value is equal to negative square root of 3 over 2. So I'm here on my thing. I'm looking for the x value. That's positive. I'm just walking around my circle. Oh, I found one there. So I get to write down 5 pi over 6. Let's see. I'm going to keep going. I see another one here. So I get to write down 7 pi over 6. And keep looking. That's the last one, right? So I'm going to write down 5 pi over 6 and 7 pi over 6. 5 pi over 6, 7 pi over 6. That's it. That's all there is to it for that particular example. Okay. All right. Let's talk tangent. Okay. So is tangent one of the things we can just read right off the unit circle? What do I have to turn it into? I need it. Good. We got to turn it into sine over cosine. Sine x over, it's really sine x over cosine x. So what I am looking for is I am looking for somewhere where my x and y value are the same, but with opposite signs. Okay. So when I go over to my unit circle and I start looking for that, I'm going to zoom out a little bit. All right. I am noticing that they're the same here. Do they have the same sign or opposite signs right there? Same sign. Okay. What about here? Same but opposite sign, right? So really what I'm looking at is this, what we reversed is it used to be square root of 2 over 2, right? And you don't necessarily have to write this part down, but if it helps you. And one of them has to be negative and one has to be positive, but we don't really know which one it is, right? Because it could be this way or it could be that way, okay? So we need both where the x and the y value are both positive and negative. All right, so we just said that it happens at x equals 3 pi over 4. Okay, I want you to keep looking. Find the net. There's one more. So decide what the last one is and write it down on your page. All right, where's the next one happen at? Good, 7 pi over 4. Okay, we're gonna start. Example 5 is basically the same as example 3. You should be able to do that one. I'm gonna talk about example 6 to start, and then I'm gonna have you do both of them. Technically, what number is always in the denominator? 1. I have to reciprocal this first. So what's the reciprocal of secant? Cosine, okay? And so it would be negative 1 over square root of 2. Is that on our unit circle? What do I have to do first to get it as something on our unit circle? We have to rationalize for like the 5 millionth time, right? So negative square root of 2 over 2. Okay, so I'm going to stop there. I want you to find the radian measures for both example 5 and example 6. Everybody try it. Okay, if you haven't yet, talk about it with your table. Everybody's checking with their table. Okay, let's check it together. So for the sine of 3 square root of 3 over 2, is sine your x value or your y value? Good. What radian measures did we get? I heard lots of things. What was one of them? Pi over 2? Pi over 3. I must not have the right. Oh, I'm looking at the wrong answer. That's why I'm writing down the wrong thing. Okay, what was the other one? Good. You guys are right. I was totally, my eyeball was on the wrong line. All right. For secant or cosine of negative square root of 2 over 2, where'd we get? 3. Good. 3 pi over 4, 5 pi over 4. Excellent. Anybody got any questions on that part? Because we're going to take it to the next level now. Okay. All right. We're going to cross out this part of the instruction. I'm only ever, what that means is, you know how we could keep going around and around and around the unit circle forever? So I could have an answer here that's pi over 6 and then go around again. Now it's 13 pi over 6 and go around again, and it's whatever pi over 6 again. Okay. That's what that 2 pi n means, is that we can keep going forever and ever. I'm going to stick to, when I give you a quiz on it, I'm going to stick to just between 0 and 2 pi. Okay. And typically that's what calculus would do next year. Okay. All right. So basically what we did on example 3, 4, 5, 6 was we did the last step of what we're going to do. The last line of work is what we're going to do on example 7, 8, and so on. Okay. So I've got to basically isolate the piece of trig, treating trig like a variable. Okay, until I get it all isolated. So how do I move the 1 to the other side? Good. So 2 sine x equals 1. And then how do I move the 2 to the other side? Divide. Doesn't it now look like what we were doing in those first 4 examples? It's identical. Okay. All right, so I assign the x value or the y value? Okay, y value. So find that y value on the graph, on the unit circle, and write down your 2 answers. Okay, what do we get? You guys have gotten really good at the unit circle. Good job. All right. I want you to try example 8 on your own. You can do it. It's almost identical to what we just did. Okay, do you agree with where I've gotten so far? Cosine x equals 1/2. Okay, so cosine the x value or the y value? X. Okay, so where did we find cosine of x equal to 1/2? Pi over 3 and 5 pi over 3. Everybody good? Okay, we're gonna make it harder than 1/2 now. Okay. It looks like we've got a little bit more combining to do this time. Okay, so we're gonna treat sine or whatever the piece of trig is just like a variable. Okay, so I notice I've got like terms. I've got to take this sign and move it to the left. It's right now under negative or subtract. How do I move it to the other side? Add it. So I've got 1 sine plus 1 sine would be 2 sine. At the same time, I'm going to move the number that is not attached to our variable sign right now, right? So I'm going to take this and move it to the other side. How do I do that? Good. All right. How do I move this 2 out in front of the sign over to the other side? Good. So we've got sine of x equals negative square root of 2 over 2. All right. Is sine the x value or the y value? Good. Go find it on the unit circle for negative square root of 2 over 2. All right, what'd we get? Good. All right, everybody try 10. Okay, I want you to check it with your table now. So everybody's checking example 10 with your table. All right, let's take a look really quick. All right, how did I move this cosine to the left? Add it. Good. So we got 2 cosine x equals, how do we move the negative or the square root of 2 over? Add it. Okay, and then how do I move the 2 in front of the cosine? Divide it. Good. So square root of 2 over 2. All right. We've got, was cosine the x or the y? X. Okay, so what radian measures did you get? Perfect. Okay, doing really good. Okay, I think all that gim kit paid off. All right, let's take a look at 11. All right, so 11, notice we got a little bit more complicated. Now we've got a squared on there that we have to deal with. Okay, we're going to still do the same thing we would if that was 3x squared minus 1. We're going to go reverse all of our algebra. Okay, so what would I do first? Add 1. Okay, so let's do that. So 3 tangent squared x equals 1. All right, what am I going to do with this 3 now? Divide it over, so tangent squared equals 1 divided by 3. Okay. How do I undo a square? Square root. What has to go in front? Plus or minus. What's the square root of 1? So I've got plus or minus 1 over square root of 3. Okay. I know that's not on my unit circle, so I'm going to do a couple of things in one step. What's another name for tangent? Sine over cosine. And I know you guys know that this exists because you guys were doing a great job looking at all the signs in the room during your quiz yesterday. I was watching. Which is good. That's why they're there. I know that that's not on the unit circle. Technically, what's underneath each one of those numbers on the unit circle? On our unit circle, what's always on the bottom? 2. Okay. So I know that those are both divide by 2s, right? We're just reversing what we would have canceled off in another type of question. Okay. All right. So that means that my x coordinate has to be square root of 3 over 2, and my y coordinate has to be 1/2, because cosine is the x and sine is the y. But the plus minus could be on either one. So this time, instead of 2 answers, there are 4 answers. Okay. So I could have positive square root of 3 over 2 and negative 1/2. I could have negative square root of 3 over 2 and positive 1/2. I could have them both positive, both negative. Okay. Because it didn't isolate quadrants for me like it has in some of the other types of problems we've done. Okay. So I want you to go around the unit circle and write down the 4 times you see that coordinate. Doesn't matter what signs are. All right. What's the denominator on all of them? You notice how the denominator is the same on all of it, right? Hasn't it that been true for all of these that we've done? It's always the same denominator. So there's a pattern there that you, whenever you're always, when you're solving these, should have the same denominator. There's a couple of, we'll get to where there's exceptions, but when you do a single one of these, it's always the same denominator. So we had 4 6s, right? All right. What did we get for the first one? Pi. What was the next one? 5 pi, and then 7 pi, and then 11 pi. All the over 6s. All right. I want you guys to take a minute and try example 12 on your own. So everybody's trying 12. All right, I want you to check it with your table now. Okay, let's check it. What did I have to move first? Everybody okay with the 3? I'm gonna do my work off to the side here. So I got 4 sine squared x equals 3. Then what? Divide by 4. Good. And then how do I undo the square? What has to go in front? Good. So sine x equals plus or minus square root of 3 over what? 2. All right, that's on our unit circle, right? There should have been 4 locations. What were all their denominators? So we had 3 in all the denominators. Okay, what was the first one? Pi, then what? 2 pi, good. 4 pi and 5 pi. Everybody good? Not so bad. Okay. There's nothing else you've understood this in trig. This is the one thing you got to make sure you can do. Okay. Well, this is probably the most useful for what we're going to do next year. All right. We're going to take it one step further here, and let's try example 13 and 14. At least 13. I only did 13 last year. We're doing on time. We got lots of time. Okay, let's try 13. I'm just curious. Okay. So I noticed that it's quite ugly, right? We've got cotangent x cosine squared x equals 2 cotangent x, and we're supposed to solve that equation. I really don't know what to do other than if that was something algebraic, I'd probably get it equal to 0 because I see a squared, right? And I know squared things, I can probably use zero product property and quadratics maybe somehow, maybe some factoring or something, okay? So we're going to take this and move it to the other side. How do I move it to the other side? Subtract it. Good. So I've got cotangent of x cosine squared x minus 2 cotangent x equals 0. Okay. Look, I have two groups, right? I've got the yellow group here and I've got the purple group. What's the very first thing I always look for when I have an equation like that? When I factor, what's the first thing I always try to find? Greatest common factor, right? Is there a greatest common factor that's in both of those groups? You don't get to use x because it's in all of them, right? The x is now part of your trig. So what's the same? What trig is the same? Cotangent. Okay. So I'm going to pull out a cotangent x. And what's left behind in the what's left behind in the yellow group? Cosine squared, right? What's left behind in the second group? -2. Good. All right. This is now a problem. So the idea is you want to take, just like when we had like an x and a y in there, we got them separated. We could then use the zero product property. That's exactly what we're going to do now. We have the two pieces of trig that were different, separated. We're going to use a zero product property on them now. Okay. And at this point, we could get one answer, two answers, four answers, six answers, eight answers. Just depends. Okay. We could get lots of different answers this time. All right. So I've got the cotangent of x equal to 0 and cosine squared x minus 2 equal to 0. All right. Cotangent is what over what? So I'm looking for cosine over sine. Technically, what's in the denominator here? 1. So I am looking for the point 0, 1. And it has to be positive 0, 1 because it wasn't a squared, so I couldn't get a plus minus. So where is... Oh, it actually could be plus minus because when I do 0 divided by something, isn't it always 0? So it could be plus or minus. So find the two places where it's either 0 positive 1 or 0 negative 1 and write it down on your page. Use your unit circle, find those two spots. Okay, what were they? Pi over 2, 3 pi over 2. Perfect. All right, I'm going to make an attempt just like I did on the other ones to now solve this. Okay, how do I move that 2 to the other side? Good. So we've got cosine squared x equals 2. How do I undo the square? Square root, what goes in front? Good. So cosine x equals plus or minus square root of 2. What's in the denominator? I can't artificially add a 2 into that one, right? The only time I could do that is if I have the tangent thing where I'm recreating the 1, right? So technically the denominator is 1. Does this exist on our unit circle? We don't have square root of 2 over 1. We've got square root of 2 over 2, but we don't have square root of 2 over 1. This is an extraneous solution, like we did with the radicals and the rationals, okay? So in this case, we just put a nice little x through it. We're not going to use that one, and those are our two answers right there, okay? Thought that was funny? All right, awesome. I'm glad I'm making you laugh. All right, I want you all to try number 14 on your own. Okay, similar idea, except that it's not, there's only one, well, the trig is a little bit different. So try it. See what you can do with 14, based on what we just did. Very similar steps. About 30 more seconds. Okay, I want you to check it with your table. So have a conversation with your table, compare your answers. Okay, I moved my 2 a sign over by subtracting. What's my greatest common factor? Good. All right. What was left behind? Okay, so because I took out one of the signs here, it would make it sine, right? And then the thing that would be left here would be a 2. Okay. All right. I got to use zero product property, so sine x equals 0 and sine x minus 2 equals 0. So let's see. Sine equal to 0, is sine the x value or the y value? Y value. So where was the y value equal to 0? What radian measures? Okay, what else? What else is at 2 pi? 0. So it's really 0 pi, 2 pi. Technically, because of that parentheses, 2 pi wouldn't be included, but I can let you get away with that. It's 0 over 2 pi. 0 is going to win. Okay. All right. And then we're going to go sine of x equals 2, right? Is 2 on our unit circle in the y spot? No. So this one, again, is extraneous. So these are our only solutions for that. Okay. All right. I think we should stop there and play GimKit. Okay, so everybody get into GimKit. Are we going to do tag, capture the flag, or Fishtopia?